the efficiency, it has always been defined within the coordinates of time. The more units of production per less parts of time. So if you produce 10 pieces of something in 1 minute, and if you can increase your production capacity to like 20 things of something in 1 minute, then you become more efficient. Right. That was the general understanding. So everything, so the industry was steered towards this. More goods in less time with more accuracy. So everything kind of perfected towards this path for the last quarter of the 20th century. But then things become more efficient and supposedly expected to be less pricey. But I think we came to some point in time where the market or the system as we know of it is saturated with its efficiency at the moment. The efficiency is something, this efficiency, the understanding of efficiency should be reconsidered to be something else, maybe in this 21st century. All these machines that I was working with or integrating at some, to a certain degree, is always thought to be faster and more accurate. Right. Like throwing arrows to a board, that arrow always hits the exact same mark. The more arrows you throw, the more efficient your machine is. That is the understanding, or at least that was the understanding. But so the energy that's put into these systems is huge human energy.
That's amazing. I love the statement that you said, which is we should redefine what our perception of efficiency is.
Yeah.
Yes.
It's fascinating. I don't disagree. And just from hearing you talk about it, it reminds me of these machines are faster, more accurate, but they're so specialized. And I guess that's what really separates it. Like, I'm interested, even before we got on here, I said, you know, one of the things I wanted to talk to you about was, I don't know what the technical terms are, but it's sort of like from an artificial intelligence standpoint, you have artificial intelligence is sort of this blanket category, but then you have very specialized intelligence, which is what we kind of have succeeded in. Like these certain things can do something really well, like identify a song or do this or that. But what they haven't cracked is artificial general intelligence. So general meaning you could throw any problem at it and it does it. So I was thinking about this in terms of the factories, and exactly like these old machines, it's like an old factory like you'd see in the 70s or something. And it's like they cut really well, they do one thing, this or that, but they're very dumb. But I know I've seen them, especially on your website and like in the Tesla factory, you have these new machines that are kind of, I don't know what they're called specifically, but I consider them like a general machine where it's more of an arm and it can drill, and you can teach it to drill anything. So it's not specialized, it's, I guess, generalized is how I would describe it.
Yeah.
And that's fascinating because then you can have a factory where, sure, maybe it's not as fast, like you're saying, it's not as quick and it's not as accurate, but it's completely flexible. At least theoretically, I imagine that would be something you could do. Like, so it's this factory of just arms and they're generalized and you can teach them to do anything, build anything, maybe.
Yeah, at least
For
within
example,
the parameters.
I was working with the Fraunhofer Institute in Germany. In Germany, they have this government supported, government funded chain of institutes called Fraunhofer institutes, and every city has one of these institutions, and every city is specialized in something, some field of science and technology. They are trying to bridge the gap between the industrial application and the scientific knowledge. So the one that I had close relationships with was in Dortmund, and they were specifically specialized in logistic systems, both internal and external logistic systems. So it's like moving stuff inside a building. It's like super high-tech Amazon warehouses and things like that. They're just moving things around, but they develop technologies around this. And the research group over there had a project for Volkswagen. The Volkswagen company produces different brands of cars as well, not only Volkswagen, and also different models of cars. But the demand is not very high for every model at every part of the year. So sometimes certain models sell more, so they have to produce more. One strategy is to install a manufacturing and assembly line for each car model. But another strategy is to make the factory as flexible as possible so that you can move around the machines into different configurations. So you can just produce a Passat today and change it into something else, so you can produce a Golf tomorrow.
Oh, fascinating.
And they were building algorithms to calculate the demand and from the market information, market data, to create some information for the factory. Then afterwards, depending on that information, the factory self-configures itself into different production lines. So you don't need to install different manufacturing lines or assembly lines. And in this strategy, they wanted to put robotic arms on top of mobile platforms so that the robots can move around and position them accordingly to the one another. And it was a huge project, like 2 million or 2 billion or 3 billion euros were funded directly by Volkswagen into the university so that they can study this. And at some point I attended few of their meetings and saw some very small work cells that they implemented these algorithms, but that was like 4 or 5 years ago. I don't know what the situation is at the moment. But
to provide some
with your analogy, like artificial intelligence is something, but general artificial intelligence is something that's more encompassing. So general manufacturing, with the same analogy, is also more encompassing. You can create a factory that produces anything that is required depending on the demand, or very flexibly.
Yeah, it's interesting prospect. I mean, I guess flexibility would be one possible judgment criteria I would post if you say that speed and accuracy wouldn't be it. I'd be interested to know if you had thought of many other criteria by which you could judge success in manufacturing. Because you mentioned we shouldn't use speed and accuracy, or maybe we shouldn't, or we could come up with something new.
If you're producing something repetitively, in my understanding, these parameters are all driven by the market demand. In the past, as far as I could remember, which is like more than, it's like 45 years of my history on this planet. When I look back, the more bigger central manufacturing or production locations than countrywide or region-wide distribution networks were considered more efficient. But to my understanding today, smaller regional manufacturing and less transportation from one location to the other is more productive. It kind of, produce at the location, consume at the location is a better it seems like a better strategy. But anything that has been designed in the past, like 20 years ago, was mostly one major big manufacturing plant and a widespread distribution network.
I guess to harken back to kind of those different parameters, there's let me also provide some context for some people that might not understand engineering too, by the way. So let's say that the typical model was, when we were thinking about, like, let's say like a plasma screen TV, when they were building those, they would build a factory specific for a specific size of screen TV. And then if they were building another one, they'd literally have to build another factory for that. And so the amount of efficiency there is very inefficient, because you want a new model of TV and you essentially have to build another one. OLED, which our phones screens use, actually helped cut down on that, because it's more like a printing type surface. So it's more malleable for that kind of thing. And so when we're talking about cars, we're actually, Elon Musk is actually talking about building his truck factory in Austin, Texas. So every time he creates a new car, he essentially creates a new factory for that model of car, right, in different places. So what we're discussing here is, we're saying it would be really powerful to have these mechanical and automated machines reconfigure themselves, so you don't have to build a whole new factory for when, you know, they're done with their line of trucks that they're making, and they can kind of pivot and then go back to making trucks later. So that's one of the things that we were kind of mentioning. So,
right. Plus,
then,
using different metrics for scoring, I'll call it efficiency, but we call it, we might even need new words of what to describe it, because if we use dollars for efficiency in manufacturing, like is often done, you get things like where you catch shrimp in the Gulf in near Texas in the United States. Then we ship them across the ocean to China to have them shelled. And then we ship them back to the United States to be consumed. And if you were, the reason being because the cost makes sense. So in terms of dollar efficiency, it actually is the most efficient. But if you were an alien looking at the planet of humans, you would tell them, no, please just shell the fish right there, or the shrimp.
And we also want to keep in mind that if somebody really digs into the chain of how the market dictates these flows, oftentimes the person who's also owns the boat that's moving the shrimp from one place to another, the people are often invested in all parts of that value chain of moving those goods around the world as well. So that's something to keep in mind as well. So the market truly is one of those things where actually it's probably the #1 indicator of efficiency, right? And so maybe that's the one that you're referring to. Maybe it's not necessarily adding more, but removing one based on what your model is. But I guess the other parameters, so what I was saying there is, like, first, it's, does this make money? Then I'm going to figure out the fastest way to do it and the best speed and efficiency. So clearly efficiency, that formula has market or money at the very beginning of it. And the question is what value chain might we want to include instead of money as that first indicator of those parameters moving forward? I think that's kind of what you were referring to, right? Like, maybe scientific discovery should be the first part of the value chain, and then moving forward after that.